Okay. Practice problem 1910, page 880. Reaction is balanced. Given Gibbs free energy standard value for the reaction, negative 102 kilojoules, and we're at a temperature of 298 Kelvin. Now let's change from standard conditions. Okay, so standard conditions, remember, means pressure is 1 atmosphere for gases. Solutions would be 1 molar. Temperature would be 298 Kelvin. And pressure is 1 atmosphere. Yeah, okay. So here what we're doing to change from standard conditions, we are changing the pressure values. Okay, we got the pressure values different. So we got a new equation for you. Another equation to solve for Gibbs free energy of a reaction. Okay, notice that this reaction has two deltaG reactions. One has the little degree sign up there. That's the standard value. That's the values that come out of the back of the book in Appendix 2B. When you change from standard conditions, so you start messing with temperature, you start messing with concentrations of solution, start messing with the pressure, then we get new deltaG values. And those deltaG values don't have the little degree sign up there. So what we have to do here, we use a new equation there. Notice that it has plus RT ln of Q. We are outside the standard conditions. We're going to get a Q. Remember, that's a reaction quotient. It's like a snapshot. You got special conditions and you want to take a snapshot, see what it is. Okay, it's like writing a K constant. Okay, products over reactants. Okay, same thing, coefficients become exponents. So let's first find our Q value. I've got the expression written there for you. I substituted in the pressures that were given for each gas. Notice a couple of them, the H2S and the H2O are squared. That's because they have the 2 in the coefficient there in the balanced equation. We've got our Q value, 1.66 times 10 to the negative 5. Next, make sure your temperature is in Kelvin, 298 Kelvin. And the R is the constant, 8.314. It's that thermo energy constant, okay, 8.314. We substitute in the values. Notice what I did with the negative 102 kilojoules. I've got to flip that to joules because 8.314, the R constant, is in joules. So everything's got to match. Use like units. So we substitute in the values, solve. We get a negative 129,258 joules, and I rounded it off to negative 129 kilojoules with 3 sig figs just to kind of match the 3 sig figs of the other deltaG value. Remember, if deltaG is negative, that means the reaction process is spontaneous. No outside sustained energy input is needed. Okay, the new value is more negative, which means it is more spontaneous than at the standard conditions.